Here we have a SAT math problem. Okay, let's go to the question. In the figure above, sine A degrees equals to cosine B degrees and BC equals to 10. If A equals to 2x negative 16 and B equals to 3x negative 9, which of the following is the area of triangle ABC? Okay, using the given information, we have to find the area of the triangle given over here, ABC. Okay, let me consider this particular piece of information, that is sine A degrees equals to cosine B degrees. Whenever the trigonometric ratios sine and cosine are equal, then the angle measures we have for sine and cosine must be complementary. That is, this angle measure A degrees and this angle measure B degrees must add up to 90 degrees. So we can write this one as A positive B equals to 90. Okay, here we have A equals to 2x negative 16 and B equals to 3x negative 9. So we can plug in this 2x negative 16 for A over here. Then I'm getting 2x negative 16 positive. And for B, we can plug in this stuff, that is 3x negative 9 equals to 90. Okay, let's combine the like terms we have over here. When I combine this 2x and 3x, I'm getting 5x. When I combine this negative 16 and negative 9, I'm getting negative 25 equals to 90. Okay, now let's solve for x in this one. For that, we have to add 25 to both sides. When I do so, this negative 25, positive 25 will cancel. I'm getting 5x equals to 115. Let me divide both sides of this equation by 5. Then this 5 will cancel. I'm getting x on the left side. When I divide this 115 by this 5, I'm getting 23. Okay, here I got the value of x, that is 23. Now, what I can do is I can plug in this 23 for x over here and here to get the two interior angles A degrees and B degrees of the given triangle. Okay, so let me plug in 23 for A into this equation. Then I'm getting A equals to 2 times 23 negative 16. A equals to 2 times 23 is 46 negative 16. Then I'm getting A equals to 30. Okay, let me plug in x equals to 23 over here. Then I'm getting 3 times 23 negative 9. Then B equals to 69 negative 9. I'm getting B equals to 60. Okay, here I got A equals to 30. That is, instead of A degrees, we can write 30 degrees. And here we got B equals to 60. And instead of B degrees, we can write 60 degrees over here. Okay, here in the given triangle, I got the two interior angles at 30 degrees and 60 degrees. What should be the measure of the interior angle over here, the vertex A? So it has to be 90, because in any triangle, the three interior angles will add up to 180 degrees. So we know that the measure of this one is 60, the measure of this one is 30. When I add them, I'm getting 90. Then the third one has to be 90, so that the three interior angles will add up to 180 degrees. And also, this is a special right triangle. That is a 30, 60, 90 special right triangle. Okay, in 30, 60, 90 special right triangle, the side which is opposite to the smallest interior angle, 30 degrees, has to be considered as a shortest leg. Okay, in this triangle, AB is a side opposite to the smallest interior angle measured 30 degrees. So this is the shortest leg. In 30, 60, 90 special right triangle, usually we assume x as the length of the shortest leg. Now, to get the length of the next longer leg, which is opposite to 60 degrees, that is the length of the leg AC, that is opposite to the interior angle measured 60 degrees, what we have to do is we have to multiply the length of the shortest leg x by square root of 3. Then the length of this AC is x times square root of 3. Now, let's consider the length of the hypotenuse BC. See, here BC is hypotenuse because it is opposite to the right angle. Now, to get the length of the hypotenuse BC over here, what we have to do is we have to multiply the length of the shortest leg x by 2, that is 2x. Always we have to remember this stuff in 30, 60, 90 special right triangle. Okay, here I got all the three sides of the given right triangle. So, in terms of x, but already we have the length for this BC, that is given in the question 10. That is, this 2x equals to 10. Now we can solve for x in this equation. For that, we have to divide both sides of this equation by 2. When I do so, I am getting x equals to 5. Okay, here we got x equals to 5. Now we can replace this x by 5. And here also we can replace this x by 5. Then it will become 5 times square root of 3. Okay, here I got the lengths of the two legs of the triangle, right triangle over here. That is AB and AC. Okay, in any right triangle, apart from the hypotenuse, in the remaining two legs, we can consider one of the legs as base and other leg as a height. Okay, in this triangle, we can consider this AC as a base and AB as a height. Now, we can find the area of the triangle using the formula. Okay, let me write the stuff over here. That is area of triangle ABC equals to, the formula is base times height divided by 2. Okay, here the base of the triangle is the leg AC. So its length is 5 times square root of 3. We can plug in 5 times square root of 3 for base. And the height of the triangle is given by the leg AB. Its length is 5. We can plug in 5 for h over here divided by 2. Okay, here when I multiply this 5 and 5, I'm getting 25. That is 25 times square root of 3 divided by 2. Okay, here I got the area of triangle ABC. That is 25 times square root of 3 over 2 square units. We find this stuff in answer choice A. The correct answer choice for this question is A.